This is the Higgs boson. The Higgs boson is a fundamental particle. The Higgs boson has no electrical charge. It has a rest mass of 125 giga-electron volts per speed of light square approximately. The Higgs boson is 130 times more massive than the proton. The Higgs boson is the second most massive elementary particle that is known by scientists. It has a spin value of 0. The Higgs boson decays in a fraction of a second. This is why it earned its name the God particle, short for the goddamn particle, because it's very difficult to detect. The Higgs boson is a quantum ripple in the background energy field, that's the Higgs field of the universe. Meaning that the Higgs boson is an excitation of the Higgs field. Every fundamental particle is an excitation of their own field. Just as an electron is an excitation of the electron field, and a photon is an excitation of the photon field. You can take an excitation of the Higgs field like this.
Imagine this body of water is a field. If I am to add energy by, say, dropping a rock into the body of water, there will be a splash. That splash is an excitation of the field. That means the splash itself is a particle, fundamental particle.
The existence and discovery of the Higgs boson means that the Higgs field can really exist. The Higgs field is a field of energy thought to pervade the whole universe. It's everywhere. When particles pass through the Higgs field and interact with the Higgs field, they get mass. The more a particle interacts with the Higgs field, the more massive it gets. For example, the top quark, which is the heaviest known particle, has a mass of 173 giga-electron volts per speed of light squared, and interacts more with the Higgs field than the electron, which is lighter. Let's talk about the origin of mass. When particles pass through the Higgs field and they interact with the Higgs field, they get mass. We all know that. But the Higgs field does not generate the mass, because if it did generate the mass, that would be the violation of law of conservation of matter, because that would be creation of mass. However, fundamental particles gain their mass via their Higgs field interaction with the Higgs boson. The Higgs boson contains relative mass in form of energy, and once the field has endowed a formerly massless particle, the particle will slow down, acquire mass, and become heavy. First, I'll tell you how the Higgs boson was created. The Higgs boson was created in the proton-proton collision, which means two protons colliding together, and the chance of a Higgs boson appearing was 1 in 1 billion. Specific events that would have happened were used to verify the existence of the Higgs boson. Since the Higgs boson is unstable and decays into more stable particles, those stable particles were supposed to be detected, but that was difficult. Instead, they searched for the Higgs boson along with the W boson, the C boson, or the top quarks. If the Higgs field didn't exist, gravity wouldn't exist, because there won't be any mass to attract other masses.